Hello everyone, my name is Mel Chowda. Welcome to my YouTube channel. Today we'll discuss about final project for introduction to data analysis. So let's start with our problem statement. So for the problem statement, we are going to create the three algorithms: support vector mechanics, logistical regression, and decision tree, and determine which algorithm are the best suit for dataset illness study.csv. Then we'll identify two recommendations for the model which is based for the dataset. Use the dataset illness.study CSV to create algorithms. After that, present and explain five key insights from the basic statistics of the dataset. And last but not the least, present and explain three key insights from the classification report. So for the dataset, we have two types of variables. First is independent variables and second is dependent variable. So for independent variable, for in our dataset Excel CSV file, we have column A to AD, total 30 attributes, which is measured as independent variable. And second one, dependent variable are column AE, that is diagnosis, which is M for malignant and B for benign. So how many algorithms we are going to use for this assignment? So in this assignment, I'll be using total three algorithms as follows. First one is support vector mechanics, logistic, logistical regression, and decision tree. Now let's go to the coding part to understand the code. So we'll go to Jupyter Notebook for that. So first step is to import the libraries. So first one, import pandas as PD, import numpys as NP from sklearn.model selection, import train test split. Then from sklearn.preprocessing, import standard killer. From sklearn.smv, import svc. From sklearn.linear model, import logistic regression. From sklearn.tree, import decision tree classifier. From sklearn.matrix, import classification report confusion matrix. We'll import all this library to perform the algorithms and assign the train and state statistics. Second step is to load the dataset into pandas data frame and print out the dataset. So our dataset name is datasets is equal to pd dot read csv. We'll be using pd dot read csv function as it is csv file, and our csv file name is final project illness study. So we'll be using dot head function to print out the top 5 rows of dataset. So dataset dot head. So you can see the dataset top 5 columns here. Next we will be using dot describe function to get the key statistics of the dataset. So dataset dot describe, it will give the key statistics of the dataset. So you can see we have count, mean, standard deviation, minimum value, 25% value, 50% value, 75% value, and max of all the row columns. Yeah. So now I'll explain each and every key statistics in the PPT. So first we'll start with area mean. So for area mean, standard deviation is 351.9, minimum value is 143.5, and the maximum value is 2501. 25% is 420.3, which means 25% of the data points have a value less than 420. 50% value is 551.1, which means half of the data points have a value of more than 551. Second one, we'll be getting data for radius mean. So for radius mean, standard deviation is 3.52, minimum value is 6.98, and maximum value is 28. 25% value is 11.7, which means 25% of the data points have value less than 11. 75% value is 15.78, which means only 25% of the data points have value of more than 15.78. Next is perimeter mean. For perimeter mean, standard deviation is 24.29, minimum value is 43.79, and maximum value is 188.5. 25% value is 75.17, which means 25% of the data have less value than 75. Only 75% 75% value is 104.1, which means only 25% of the data points have value of more than 104, means 75% of data are below 104. Last one is symmetry mean. So for symmetry mean, standard deviation is 0.0274, minimum value is 0.106, and the maximum value is 0.304. The mean of symmetry mean is 0.181. 25% is 0.1619, which means 25% of data points have a value less than 0.16. The confusion matrix and classification report. So for confusion matrix and classification report, we'll first understand the coding part. So let's go to Jupyter Notebook for coding part. Before doing the algorithms, we'll be assigning x and y independent variables. So x will be assigning dataset dot drop diagnosis. So we'll be dropping diagnosis from the dataset and assigning all the remaining columns to the x variable, and y will be only diagnosis, which is our dependent column, and we'll be assigning to arranging in it to two numpy array. Then second step is to split dataset in training and testing database. So we'll use xtrain xstate, ytrain ystest. So it equal to train test split xy stratify y, test size is 0.20. 0.2 means 20% of data will be going for testing, and we have assigning random state as 100. Last, before the algorithms, will normalize the data. So for normalization, we are using standard scalar. So SC is equal to standard scalar. X train scale is equal to standard scalar dot fit transform. X train X test scale is equal to standard scalar transform X test. Now we'll start with the algorithm. So first algorithm is support vector mechanics. So for support vector mechanics, train support vector classifier algorithm and test it. So we'll be using SVM model. So SVM model is equal to SVC. Inside the bracket, we are using cardinal as linear and random set is 100. SVM model dot fit. So we'll be fitting the dataset X train scaled and Y train. So SVM predictions is equal to SVM model dot predict X test scaled, and we'll printing the confusion matrix and classification report as below. Support vector mechanics. So support vector mechanics algorithm used for classification problems in machine learning. The goal of the SVM algorithm is to create the best line or decision boundary that can segregate n-dimensional space into classes so that we can easily put the new data point in correct category in the future. This best decision boundary is called hyperline. So we can see the confusion matrix and the classification report as below. Now let's go to understand the confusion matrix and classification report of logistical regression. Let's go to coding part. So for logistic regression algorithm, we are using log model. So log model is equal to logistic regression. Inside the bracket solver, we are using linear and random set is 100. Log model dot fit x train scaled and y train. Log prediction is equal to log model dot predict x test scaled, and print the logistic regression, and we will be printing logistic confusion matrix and classification report as below. Logistical regression is used for predicting the categorical dependent variable using a given set of independent variables. Logistic regression predicts the output of a categorical dependent variable. Therefore, the outcome must be a categorical or discrete value. So either it can be yes or no, 0 or 1, true or false, etc. But instead of giving the exact value as 0 and 1, it gives the probability value which lies between 0 and 1. So we can get the result in 0 and 1, not the exact 0 or 1 between values. So logistical regression is a significant machine learning algorithm because it has the ability to provide probabilities and classify new data using numerous and discrete dataset. So in the image, we can see the confusion matrix and the classification report. Now third one is decision tree. So for decision tree, we'll go to the coding part to understand the coding. So for decision tree, we are using tree model. So tree model is equal to decision tree classifier, and we'll be using random set as 100. Tree model dot fit x train scaled y train. Tree predictions is equal to tree model dot predict x test scaled, and we are printing confusion matrix and classification report of decision tree model. Decision tree is a unsupervised learning. Decision tree is a supervised learning method used in data mining for classification and regression methods. The decision tree creates classification or regression models as a tree structure. It separates a data set into smaller subset, and at the same time the decision tree is steadily developed. The final tree is a tree with the decision nodes and leaf nodes. A decision node has at least two branches. The leaf nodes show a classification or decision. So we can see in the image the confusion matrix and the classification report of the decision tree. Now let's get the key insights from classification report. So first one will start with support vector mechanics. So precision, how many are correctly classified among the class? Benign has higher precision than malignant, which is about 1%. The macro average and weightage average of precision are 0.96. Recall. So recall says how many numbers do you find over the whole number of element this class. The macro average and weightage average of recall are 0.95 and 0.96 respectively. F1. Harmonics mean between precision and recall. The macro average and weightage average of the F1 score are 0.95 and 0.96 respectively. The accuracy of F1 score is 0.96. Second one is logistic regression. So for logistic regression, precision means benign has higher precision than malignant, which is 4%. The macro average and weightage average of precision are 0.97. How many recall? How many numbers do you find over the whole number of elements of this class? The macro average and weightage average of recall are 0.97. F1 score. So F1 score is harmonic mean between precision and recall. The macro average of F1 and weightage average of F1 is 0.97. The accuracy of F1 score is 0.97 for logistic regression. Last one, key insight of decision tree. So precision, benign has higher precision than malignant, which is about 6%. The macro average of precision is 0.91 and weightage average is 0.92. Recall, The macro average and weightage average of the recall are 0.92. F1 score, harmonic mean between precision and recall. The macro average and weightage average of the F1 are 0.92. The accuracy of F1 score is 0.92. Now the question, which model I'll be suggesting to Mr. Hughes for this dataset. So I'll be choosing the logistic regression algorithm for Mr. John Hughes. So I'll be recommend the logistic regression algorithm to Mr. John Hughes for the dataset illnessstudy.csv. As the precision is highest among all three algorithms, 0.99, the accuracy is 0.97 for the algorithm, which is maximum compared to the other two algorithms. The performance improvement of logistical regression model. So we'll be using two recommendations. First one is hyperparameter tuning. Each algorithm has its best set of hyperparameters, which leads to maximum accuracy. There is no specific way to identify the best hyperparameters of the model, only we can apply the trial and error method. Second one is error analysis. For each of your model, go back and look at where they are falling. You might end up finding that the same of your model work well on one part of the parameter space while others work better on other parts. If this is the case, then ensemble techniques such as voting classifier techniques often gives the best results. So use the error analysis to improve the performance. Thank you.